Boom. There was half an ounce right there. We just put a half ounce in the system. So we got some dye in there. Now let's go to our charge. Our car calls for 27 ounces. So 16 ounces to a pound. And so you've got 4 and 7, so that would be 1 pound, 11 ounces. So that's what we're going to add here. So we're going right here to a 0. Then we're going to go to 1 pound. And then we're going to go to 10, 11 ounces. Now, we're going to go to change the charge. Notice it says the mode is high side charge. We don't want to charge on the high side. Never charge an air conditioning system from the high side. The only time you can do that is if the vehicle is not running. So, we're going to go to low side charge, and then we're going to go to start. Low side charge in progress, do not disturb. Do not pass go, do not collect $200. All right, we've got the car charged with a refrigerant of 1 pound, 11 ounces. The air conditioner is on, the engine's running. Wow. It's still cycling on and off. It's off right now. Now it came back on. The low pressure cycling switch is activated on this car at about 22 or 3 psi. That keeps the system from freezing. All right, so look how low our pressures are still very low. Here's the problem. The problem is that the blower motor, remember your refrigerant, your air conditioning theory, your blower motor is not blowing at all. So there's no heat being transferred from inside of the car into the refrigerant. No heat transfer, there's nothing to displace, so the pressures are low. So I dare say if we were to get the blower motor fixed, then we can see our pressures where they need to be. It cut out about 21 psi. All right, we had to grab another car because the one that we were looking at, the blower motor did not work, as we talked about. And right now, this car has got the proper amount of refrigerant. I did a performance test on it. The air coming out of the vent was 40 degrees. The 40 degrees coming out of the vents, that's perfect. Couldn't ask for any better than that. Well, if 40 is good, would 38 be better? Would 37 be better? Well, if it gets too cold, remember you run the risk of the evaporator freezing up. As the air conditioner runs and condensation takes place on the evaporator fins, then that water forms, and if it's too cold, it'll turn to ice. Eventually, it'll freeze the evaporator, and a sheet of ice will cover the whole evaporator. So it's a fine line between where we want the temperature coming out and it being too cold or not cold enough. So right now we're going to look, and we've got this good running system, and I want you to take a look at our gauges in our machine here. All right, this thing, there's still not enough heat in this shop to cause the air conditioner to have to really work hard. So you'll notice that even though our numbers are more like what we think they ought to be, when they keep running. Topping out about 175, and it's running down to about 21 right there. It's just because there's not much heat being displaced. But right now, I'm going to simulate a problem. On our condenser, we have a fan behind the condenser. It's right at the radiator. That fan has two purposes. One, it pulls the heat off the radiator to cool the engine, but the other purpose it serves is to pull heat away from the condenser, keep the inside of the car cool, even if the car's not moving. Your condenser fan does not have to run all the time for the air conditioner, but you must be moving. Once in a while, you get a customer that complains, wow, my air conditioner works great while I'm riding down the road, but when I go through the drive-through, when I come to a stoplight, the cool air goes away and the air is not cool anymore. So what we're going to do on this one is I'm going to show you an easy way to diagnose this problem. Now remember, the air conditioner works well while you're riding down the road. I'm going to disconnect the electrical plug going to the condenser fan. What I want you to do is I want you to continue to watch our gauges. Okay, particularly watch the high side gauge. It's not cycling anymore. The heat's not being removed. Continues to rise, continues to rise. No heat is being taken off of the condenser. So that heat is going right back into your low side, going back into the evaporator, and now these pressures are rising because of that heat. And look at what it's doing. I want to catch this before it gets too high in danger of explosion. We're upwards of 400 PSI now. Let's go ahead and plug it back in. 3, 2, 1. Watch how fast it comes down. That heat's being displaced. And now we continue to get more of a liquid going back into the evaporator. By the way, I've had the heat running inside the car this whole time with the car in air conditioning mode. I just turned the temperature up. The air conditioner is having to work a little harder. Now we've got 200 PSI. Well, it just went down there some. It just tripped it. But it was having to work just a little bit harder now. So this is just the first segment of what we're doing. How we're going to look at how to diagnose air conditioner problems. Everything is in the gauges. Everything is in the temperature of the lines. Everything has to do with air movement across the evaporator and across the condenser. So hopefully this first little segment here will help you to understand a little better and get you familiar with the machine, some of the tools we're using. So, see you guys next time.